Now we have the chronSIM module, which will actually allow you to simulate such a model and show you actual behavior, timing behavior of your model. So in this case, I loaded in a model of an engine management system. It is a simple demo system here, but it's equivalent to some of the real-world examples. So in this case, we modeled one ECU, which is the resource right here. It has one core, and we have certain peripherals that we can attach to this ECU right here in the model. So we have, for example, we have a timing interrupt right here, and another one. We have two timing periodic interrupts that come in here. And we have another one, which is a communication interrupt. In this case, it comes from a flex ray. And then we have another interrupt which comes from the engine. So basically the crankshaft rotation will be modeled here, which is an event-based interrupt. So it doesn't come at specific times. It just depends on the behavior of your system. Down here you can see the scheduler. As you can see, we support hierarchical scheduling, as Tapio already mentioned. So we have the first level is always the interrupts. We have highest priority. They're scheduled right here. And then as the second level, we have the O6 scheduler, which is scheduling all my tasks that I have defined in my system. So you can see there are a number of tasks defined here. Some of them are related to the time periodic interrupts, and some of them are related to the hardware, the crankshaft interrupts, and some of them are related to the communication. If you look down here in the model, you see simulation, which you can define, and this is already predefined. So you can see, for example, for these four interrupts I defined, for each one of them, I have a simulation defined, which gives me the time at which these interrupts come in. So you can also see that with the different colored arrows right here. So basically, these interrupts will then be applied to my model up here, and they come in these pins up here. So now I can go ahead once I defined all my components in the model. I'm ready to start a simulation. What this does is actually takes all my information that I defined, and it compiles this into a runtime model. So it'll actually compile an executable for me right here, which then is a runtime model of my simulation. So I could actually take this executable and run it in like a batch mode or something. It's not always required to run it out of the user interface right here. So this will just take a few moments for it to complete. And then you can see this is a new window that's open, which is my runtime model. And in this case, we have a task state diagram. What it represents is that for each task that is running on the ECU, in this case, we just have one resource. For each task, we have a timeline down here. And for each task, we represent the different states that the task can be represented in. So I can just go ahead and start my simulation. And then you can see that the display shows me a runtime representation of my timing behavior in my model. So I'm just going to stop the simulation right here, which gives us enough data to look at. So as you can see, I can maybe zoom into a portion of it so it's easier to see. As you can see right here, you see the different interactions between these tasks. So some of the tasks are activated, but due to preemption and low priority, they actually start later than the time that they're activated and so on. You can see there are already certain errors marked in this chart right here. And for example, this is an activation limit error. It means that this task right here, before it was able to run, it actually got another activation, and this is an RTOS error. Where do these red indicators come from here? I have specific requirements already defined. One of them is that there are no RTOS errors allowed. So due to the activation limit of 1, which was defined before, I get an RTOS error right here because I have a second activation for the same task. And I can, for example, click on this link right here, and it will show me all the instances within my simulation time where I had errors occurring. So I could basically, by clicking on one of these links here, I could jump to the next instance and take a closer look on what actually happened in my model. So the same mechanism works, for example, for response time requirement. I can set a certain maximum time for my task, and if this time is bigger than 1.25 milliseconds in this case, then it'll throw me a red flag right here, and it'll show me where are my errors within the timeline. So as I said before, you can jump to certain instances of your errors and then take a closer look. You could also, you have a list of requirements right here, but if you have more than 2, if you have a whole list of requirements, you can already predefine them and then basically import them into your model. So I have prepared, let me just remove these so you can see that. So I have prepared a file that contains some requirements, as you can see. And then I load these requirements in, and in an instance, the model analyzes these requirements and shows me in an instance are they met or not. So you can see in these red flags, are they met or not. And as you can see, you can also group your requirements. So you have a response time group and group these in here, and then if they're summarized according to the number of requirements that are met. So in this case, we have a 50-50 match. This one of them matched and one of them didn't. You see this column back here called reference. In this column, you can basically link into another requirement system, which, for example, could be doors. So in this case, you could link just to doors requirements by adding a link in this column right here.